Hi everyone, today we're going to look at a lesson on multiplying and dividing monomials. If you recall, monomials are an algebraic expression consisting of one term. So let's look at some examples of how to multiply monomials. In this case, it asks us to expand and simplify. We know that 2 to the power of 2 is 2 times 2. And 2 to the power of 3 is 2 times 2 times 2. And if we simplify this, we see that there are 5 2's multiplied. So then it is 2 to the power of 5. In this case, it's a similar example with the variable x. We have x times x, which is the expanded version of x squared, and x times x times x, which is the expanded version of x cubed. Altogether, we can simplify this by x to the power of 5, as there are x's multiplied 5 times. And in this case, we have 2x cubed times x to the power of 5, 2, and x cubed can be expanded to x times x times x, and x to the power of 5 can be expanded to x times x times x times x times x. And simplified, this version is 2 to the power with, my apologies, 2 times x to the power of, we have 1, 2, 3, 4, 5, 6, 7, 8. X is multiplied by itself, so 2x to the power of 8. Now, can you see a pattern between the powers that's initially given to us and the power in our final answer? Same way, here's the 2 powers and the final answer, and the 2 powers and the final answer. If you have seen the pattern, then you are correct. When multiplying monomials, we can add the exponents on powers with the same base. So if we have a to the power of m and a to the power of n, then we can add m and n as long as the base is the same. In this case, it is a. Let's look at a few examples. X to the power of 2 and x to the power of 4. We simply add the 2 exponents together because our bases are the same, which is x, and 4 plus 2 is 6. So our answer here is x to the power of 6. Again, we have 2a squared y cubed times 3a cubed y to the power of 4. If you remember from our previous lessons, you have to multiply the numbers with the numbers, the operation, whatever the operation is in between, the numbers with the numbers, the variables with the variables. In this case, we multiply the 2 and the 3 together. And then we can add a squared and a cubed with the exponents, and y to the power of 3 plus y to the power of 4. The exponents can be added. 3 times 2 is 6. A to the power of 5. And y to the power of 7. All right. In this case, we have 3 monomials. However, all the bases are the same, which is m. So we can simply add the exponents together. And m on its own is m to the power of 1. And now our final answer is m to the power of 8. All right. When you are looking at powers of a power, in this case, we have x squared, which is to the power of 3. Here, we can expand this as such. So x squared times x squared times x squared. And in this case, we can further expand this as x times x, which is this first x squared, and then x times x again, which is the expanded version of the second x squared, and x times x again, which is the third x squared expanded. And we have x to the power of 6 because x is multiplied by itself 6 times. If we do the same thing for this next example, which is x to the power of 3 to the power of 5, we can expand the first exponent as such. So x cubed is, x cubed is multiplied 5 times by itself. And if we further expand this, it would become a long series of x's, but we also know from our previous multiplication of monomials that we can simply add our exponents with the same base. And in this case, we will have x to the power of 15. Once again, do you notice anything in terms of the exponents that are given and the exponents that we get for the final answer? And if you do notice the pattern, then that is our principle of power of power. To simplify a power of a power with the same base, we multiply the exponents. Again, it must be the same base. So for example, if we have a to the power of m, which is all to the power of n, then we can multiply m times n. So if we continue with that principle to simplify these examples below, we can say x 2 times 3, and that's the powers, which would be x to the power of 6. Again, we have y to the power of 3, which is all to the power of 4, so we multiply the powers with the same base to give us y to the power of 12. And one more example, p, the powers are 2 and 4, so we multiply them, which would give us p to the power of 8. Anytime when you have an exponent outside the brackets, everything inside is raised to that power. This is not something new. We've seen this in our last cycle as well. So if we are looking at 3x entirely to the power of 2, the power of 2 applies to 3 and to the x. 3 to the power of 2 is 9, and x squared is in its simplest form, so the answer is 9x squared. In this case, the power of 4 right here is applied to both the x and the y. So we have x cubed to the power of 4 times y squared to the power of 4. And we know through our principle of power that we can multiply. Let me fix that for you. Not sure what happened. And there we go. All right. So x 3 times 4 and y 2 times 4. And our final product is x to the power of 12 and y to the power of 8. Once again, we have a 3, an a squared, and a b cubed for this next example. So the power of 4 applies to the 3. It applies to the a squared. And it also applies to the b cubed. 3 to the power of 4 is 81. A squared to the power of 4, we can simply multiply the 2 once again. We can simply multiply the 2 and the 4, which is to the power of 8. And b, simply multiply the 3 and the 4 to the power of 12. And that is how we look at power of products. Now let's jump into dividing monomials. In this case, we have 2 to the power of 8 divided by 2 to the power of 3. If we expand this, 2 to the power of 8 can be expanded to 2 times 2 times 2 times 2 times 2 times 2, and you get the flow. 2 multiplied by itself 8 times, divided by 2 multiplied by itself 3 times. Through our integer operations, we know that when a number divided by itself would give us 1. So this pair of 2 would give us 1. That 2 divided by 2 would give us 1. That 2 divided by 2 would give us 1. And we have 2 to the power of 5 remaining. Because 2 times 2 times 2 times 2 times 2 can be written as 2 to the power of 5. And anything multiplied by 1 is itself. So then the final answer is 2 to the power of 5. In this example, the same way, x to the power of 5 can be expanded as such. And x to the power of 2 can be expanded as such. X divided by x is 1. X divided by x is 1. Anything multiplied by 1 is itself, and what is remaining is x to the power of 3. Once again, do you notice any pattern with the exponents that are given in our question and what we end up with as the answer? if you have noticed, then the principle of quotients is when dividing powers, we subtract the exponents of powers with the same base. Okay? For example, if you have a to the power of m divided by a to the power of n, then you can subtract m and n as long as it's got the same base. Let's look at some examples. M to the power of 7 and n to the power of 5 divided by m to the power of 1, in this case, as it's not mentioned, n to the power of 2. So we can simply subtract the powers from the same base. And in this case, we end up with m to the power of 6, n to the power of 3. All right, let's look at the next example. It's a little bit tricky to write on the notebook app with an iPad, so I'll try my best here. So the next example is we can subtract the exponents of x as they are the same base, and then subtract this exponents of the y, which will give us x to the power of 1 and y to the power of 1, which we can simply write as x, y. In this case, we have numbers, and dividing numbers is not a new concept to us. We have seen that many a times. So 81 divided by 9 stays as such. A to the power of 8 minus 5, and b to the power of 3 minus 1. And that leaves us with 9, a to the power of 3, and b to the power of 2. Once again, 3 divided by 3. We subtract the exponents of the same base. And 3 divided by 3 is 1. 3 minus 3 is to the power of 0. And 3 minus 2 is 1. Okay. In this case, 1 times anything is itself, so m to the power of 0, n to the power of 1. Now, what does m to the power of 0 mean? We'll look at it in the next slide. So let's say we have 2 to the power of 3 divided by 2 to the power of 3. Let's expand this for a second, which is 2 times 2 times 2. And the base is also 2 times 2 times 2. We know that anything divided by itself is 1, and we have seen this before as well. So all of these would give us 1. So 2 to the power of 3 divided by 2 to the power of 3 is 1. In the same sense, x to the power of 5 divided by x to the power of 5, we can also, using our principle, write it as x5 minus 5, x to the power of 0, and we know that anything divided by itself is 1. Therefore, anything to the power of 0 is equal to 1. Okay? 5 to the power of 0, 1. X to the power of 0, 1. 3x squared, and this entire thing, remember those brackets, to the power of 0 is also 1. You can have a trillion to the power of 0, and the answer will be 1. So let's evaluate these expressions. Okay, first it asks us to simplify, then substitute in the variable for which the value is given. Okay. All right, so we have x cubed times x to the power of 4 divided by x to the power of 5. We know that we need to take care of multiplication first, and therefore that would be x to the power of 7 divided by x to the power of 5. And dividing monomials, we know our principle is that we subtract the exponents of the same base, which gives us x to the power of 2. And in this case, we know that the value of x is 3, so we substitute that in for the variable, and 3 squared is 9. Let's do one more example. We need to multiply first, so x 5 plus 3, y 2 plus 4, and we do this because the principle of multiplying exponents with the same base is to add the exponents. So we have x to the power of 8, y to the power of 6, divided by x squared, y to the power of 5. And the principle of quotient is that we subtract the exponents with the same variable, which here gives us x to the power of 6 and y to the power of 1. And now we have our values for each variable. So let's substitute them in. And now we follow BEDMAS to solve, which gives us a final answer of negative 1,458. All right, you have your practice work online, as always, and the answers will also be uploaded. Hopefully this video lesson helps you work through multiplying and dividing monomials. Stay safe, everyone, and hope to see you all very soon.